please open to page 168 in your student journal. Today we're going to start looking at properties of exponents. And before we do, I just want to take a little time to review some of the vocabulary involved. If we have x to the third power, the x is our base, the 3 is our exponent, and if you put the whole thing together, so the x to the third power, the whole thing together, is known as a power. So just a little reminder for you, we're going to be using some of those terms today as we explore the exponent properties. So just to touch on those real quick. The first property we're going to look at involves when we multiply two powers together. Let's take a look at letter I. What I'm going to do is write out what 2 to the second power actually means. It means 2 times itself. Then 2 to the third power means 2 times 2 times 2. I multiply 2 3 times. So now I take a look, and now I'm multiplying together 1, 2, 3, 4, 5 2's. So I can also write that as 2 to the fifth power. Let's take a look at part 4. Same idea. X to the second power, or x squared if you'd like to say it that way, means x times x. X to the sixth power means x times x times x times x times x times x 6 times. Now if I look at how many x's are being multiplied together, I count them out and I notice that I have 8 of them. So it's like x to the 8th power. Now if we look at the two examples that we expanded out to simplify, we can notice a pattern. To get 2 to the 5th power, what could I do with 2 and 3 to get 5? Well, I can add them together. With x to the second times x to the 6th, I have a 2 and a 6 for my exponents. To get 8, I can add them together. So when we're multiplying two powers that have the same base, so you're multiplying, you have the same base, you add the exponents. If the bases are different, this rule won't quite work for us. Our second property, if we go to part B, involves division. If we look at number 1, I'm going to use the same technique I did in letter A. I'm going to expand out what 4 to the third means and what 4 to the second means. So 4 to the third means 4 times 4 times 4. 4 to the second means 4 times 4. Now, since I'm dividing, 4 divided by 4 gives me a 1. 4 divided by 4 gives me a 1. So I'm left with just a 4. Now, that 4 really does have an exponent. Its exponent is a 1. We just typically do not write the 1 for the exponent, but I just wanted to refresh you on that. Let's take a look at part 3. X to the 6th, we're going to multiply x 6 times. X to the 3rd, we're going to multiply x 3 times. Since we're dividing, x divided by x is 1, x divided by x is 1, x divided by x is 1. So I'm left with x to the 3rd power. Now we don't want to have to take the time to expand them out, so let's see if we can come up with a shortcut, like we did for multiplying. My end result of my exponent, number 1, was 1. I have a 3 and a 2 for my exponents. So to get the 1, I subtract the exponents. So we have 4 to the 3 minus 2. We have a 6 in the numerator, a 3 in the denominator in part 3. So if I subtract those exponents, I get my x to the third. So when we're dividing, and we have the same base, we subtract exponents. And just put a little note here, the top exponent or numerator exponent minus the bottom exponent. The last piece I want to look at, our third rule, is what happens when we have a power, so a base with an exponent inside the parentheses, and then there's another exponent outside the parentheses. How do we handle that? Let's take a look at number 1. 2 to the second power means 2 times 2. Then the exponent on the outside says, hey, wait a minute, you have to do that 4 times. So if we expand all of that out, we end up with 1, 2, 3, 4, 5, 6, 7. We end up with 8 2's. 2 to the 8th power. Let's take a look at part 3. Y to the third power means y times y times y. Then the outside exponent says, hey, wait a minute, you have to do that 3 times. So I end up with y to the 9th. I end up with 9 y's. So when you have a power, so a base with an exponent inside the parentheses, and an exponent outside the parentheses, multiply all inside exponents by the outside exponent. And we're going to see this in an example. Watch out for exponents of 1. The 3 basic properties of exponents we just went through will help us simplify all of our exponential expressions. If you want a nice summary of all the properties of the exponents, let's turn to page 171 in your student journal. On page 171, what you're going to find, all the different properties, the property in words, the properties where you have numerical bases, and the properties where you have variable bases and exponents. So the first property we went through, that's when we're multiplying 4 to the 6th times 4 to the 3rd. We end up with 4 to the 6th plus 3. That's when we added our exponents, and we got 4 to the 9th. When we divided, we can see in the next one, when we divided, we had the same base, and we took the top exponent and subtracted the bottom exponent. So on page 171, you'll find a summary of all the properties. That can be a very powerful resource for you. Let's go ahead and turn to page 172. On page 172, I want to try out just a couple examples to show you how these exponent properties will be put into action. I want to take a look first of all at number 20. Number 20, there's going to be a couple different properties there. Let's start with the numerator. In the numerator, we have a c to the fourth and a c to the third. I have the same base, and I'm multiplying. I'm multiplying, and I have the same base. So if I need to, I could flip back to page 171. I could also flip back and look at the notes we did on page 168 if I needed a resource. If I check those things out, I see that when I'm multiplying with the same base, I add the exponents. So I'm going to have c to the 4 plus 3, which is c to the 7th. My c to the 6th in the denominator, I haven't done anything with that yet. Now, I have a division problem. Again, I could flip to page 171 and refresh myself what to do when I'm dividing, or I could flip back to page 168. I have the same base, and I'm dividing, so I subtract my exponents. We end up with c to the first power. Again, you don't have to write the exponent of 1. That's okay. Now, I know you might be thinking, Miss Golly, I didn't remember those properties right away. It will take some time and practice for you to get used to when to do which thing, when to add, when to subtract, and when to multiply. Just one more example, because I want to give you guys really a chance to try these on your progress check. I want to look at number 21. I told you guys we had to watch out for the exponents of 1. I have negative 4d to the power. I don't see any exponents inside the parentheses, and I know my rule, if I check back to my notes, my rule is I need to multiply inside and outside exponents. So that's where I have to make sure that I add in those exponents of 1. So I'm going to end up with negative 4 to the 4th power, and I'm going to end up with d to the 4th power. I multiplied those exponents. Now you might be wondering, Miss Golly, why did you put that negative 4 in parentheses? Negative bases can be very, very picky. If I have a negative base and an even exponent, let me show you what happens when I put parentheses and when I don't put parentheses. I'm just going to do it in my calculator real quick, because I'm not sure of 4 to the 4th power at the top of my head. If I go to my calculator and I just type in negative 4 to the 4th power, I'm going to get negative 256. If I put my negative 4, my base of negative 4 in parentheses, and now to the 4th power, I get a positive 256. So if you have a negative number that starts in parentheses, you need to make sure that in your calculator you also put in parentheses, otherwise you're going to come up with the wrong sign. And you'll see some of those in your practice. Don't be afraid to ask questions about how to use your calculator and when you need parentheses or when you don't need parentheses. Don't be afraid to ask those questions. So negative 4 to the 4th power is 256. And then d to the 4th power, we really don't need those parentheses there. So just be very, very careful when you have those exponents of 1. They're really, really not written. Something like question 18, it's very easy to see. I have an exponent of 5 on the inside, 3 on the outside. So I'm going to do 5 times 3, and I get 15. Again, it's going to take some time and some practice. So at this time, what I would like you to do is please try out your progress check. Use all of your notes as a resource to see where you're at.